And with that, it is my pleasure to introduce Robert Hendricks, the chair of the Georgia Technology Summit for this year. Welcome, Robert.
Good morning. We're running through this really quick. Let me try that again. Good morning. All right, there are people out there I can't tell with this bright light in my eyes. I'm a Georgia native. I have had the pleasure of working with TAG now almost 10 years. I live just north of Alpharetta in a city called Cumming, so needless to say, I flew in last night and I stayed at the hotel across the street so I could make it here on time. Obviously, some of you got that joke. You live up 400. One of the things that we started out with TAG years ago was this idea that we could make Georgia a top 5 state in the United States in technology. TAG has been an engine behind that. And I will tell you that this past weekend, as I was thinking about this event, reflecting back on the years of service that I've had with TAG, I started doing, my own version of research to validate, do we, with all the types of measures that we could put in place, is Georgia a top 5 state? So obviously I immediately turned to Google. By my math, I think Georgia is actually number 4. I think that's a really big deal. I remember, I work off of Windward Parkway right now. I remember the first time I visited a relative on Windward Parkway and there was nothing there but cow pastures. I remember coming to Atlanta and that really small restaurant, the round one with the blue dome, was the tallest building in the city. So for those of you that are part of Georgia and part of this great city, and everything that goes along with it, I want to congratulate all of you for where we are today. This is an amazing state that is growing by leaps and bounds in technology. As we look at the State of Industry report today, you'll see that in many, many sectors. But as I think about this event and I think about chairing this event, I have to recognize all the members that are on that committee as well as all the board members for TAG, because we all share that same vision, that same mission. We all give our time, we all put effort into it. We all pressure the sponsors, as you all saw up there, and thank you all for that. But I want you to know that there's something worth it in the end, and that is this is an amazing state with an amazing industry built around technology in many, many sectors. And I'm very proud to be part of that. And at this point, I'd like to give a round of applause for this state and what it's accomplished, if you don't mind, please. So kind of off the stage of Georgia and back to the event, the theme for this event was innovation discovery. And as you might imagine, every year when you have something as amazing as this summit event, we spend a good many hours trying to figure out what the theme of the event is going to be, which basically means we argue a lot. We throw out the word technology and innovation. We do wordplay games. Somebody goes to some website that generates mission statements, not Dilbert, but that generates themes and topics around innovation and technology that we can use. As you think about innovation discovery, one of the things we wanted to do this year is we looked at the satisfaction survey results from all of you over the past couple of years, was we really wanted to pay close attention to, and I'll use this word correctly, our customer, which is each of you. And so we tried to bring this event this year back to some of its roots and focus on innovation, focus on the top 40, focus on what's great about this city and this state, and what has made us a top 4 state. And if anybody wants to disagree with me, let's have a discussion in the AJC so we can get a lot of press about it. How about that? But really, we wanted to focus on it. And so one of the things I'd ask you as you think about the event today is, before you leave, there will be survey cards out there. Please, please take a couple of minutes. Tell us what you didn't like, and tell us what you did like, and tell us what you want to see more of. Because this event is really for all of you. It's for you and for this community. And as we think about innovation discovery and we think about technology in the state and we think about what this event is all about, we really need your input because we want to continue to grow it. I want to continue to look out here in the darkness and see lots of seats filled with lots of people who come to enjoy one of the greatest technology events in this state on an annual basis. So to get that started, most of you noticed behind me there's a bit of a band. And so we wanted to start off this event with something a little bit different. So I have the pleasure of introducing Shimon, the jazz-playing robot.
Thank you very much. I'm Gil Weinberg, professor at Georgia Tech, director of the Center for Music Technology. And this is Mason Breton, a PhD student, about to get his PhD, hopefully in a couple of weeks. We develop robots that listen to music, understand music like humans, so they understand chord progression or consonance and dissonance or rhythm. But then when they improvise, when they play back, they use algorithms that humans would never use. And the idea behind it is that they will listen to me and connect with me as a human, but then they will improvise like no human can and create music that humans are not likely to create. In a way, surprising me and hopefully inspiring me and everyone who plays with them to create new kind of music and to expand the horizons of what music can be. So we're using algorithms such as genetic algorithm and fractals and all kind of sophisticated processes that humans don't use in order to generate new and interesting and exciting music. The next piece we're going to play actually works a little different than the first one. Here the robot would listen and try to find what motif I'm playing, and then it have a set of rules of what motifs or musical segments it will play back to me. I never know what it will play back. Sometimes it decides not to play, sometimes it decides to play, and we're all kind of improvising together to try, yeah, I know, robots. And we try together, and every time it will sound a little different. And it's called Bafana. Next, Mason is going to explain a new approach for robotic musicianships that he has been working in for his PhD.
Hi, everyone. So what you just saw was Shimon listening to what Gil's playing on the piano, and you create this sort of interactive dialogue between what's going on. But then we can also get Shimon to generate music completely autonomously without any additional human input. And what we do is we use machine learning and deep neural networks, and we train a lot of these networks based off of big data, so lots of music, everything from Mozart to John Coltrane. So it just learns to generalize music as a whole. And then from that, it learns how people compose and how people improvise, and then using these networks, is able to generate its own compositions. So here's something that Shimon composed completely autonomously.
So in the next 10 minutes, I'm going to show you some of the other projects we're working on. We are developing multiple robots. As you can see, Shimon is on the side. Hailey was the first robot. It actually played only drums. In the middle, there is Shimmy, which is an effort to commercialize this technology. You are all here in TAG, so I think you can understand trying to commercialize things. And of course, this is complicated and big, and probably you don't want this in your home. But the small one, but if you do, call me later. The small one is like a speaker dock that have musical understanding. It understands beat. It understands chorus versus verse. And based on that, it can move and basically be a speaker dock that you can put your phone in, and also dig music with you. When it plays the music, it can respond to the music. I'll show a quick video explaining how Shimmy works.
In a way, Shimmy started out as an animated character on the screen, where we worked to try to nail down his personality, and then we took that and transferred that into the real world.
It was important to us that Shimmy be able to work as a great loudspeaker. So we work to combine high-quality drivers and amplifiers with the smoothest, most quiet motors available. Inside the robot, we're taking care of all the low-level control of the motion, but all of the personality and intelligence, really the heavy lifting, is being done on the smartphone end.
Shimmy, look at me. Do you have Justin Bieber? Do you have hot chocolate? Let's hear it.
And one of the things that's really cool about that is that if you upgrade your smartphone and gain new capabilities, you're actually giving new capabilities to your robot, too.
It also learns you. It looks at you, so it knows if you like a song or don't like a song, and personally become your musical buddy.
Okay, so that's a little personal robot that you can play with. And several years after we developed this robot, we got an email from Jason Barnes, who said that he saw the Shimmy and Shimon robots online, and that he was a drummer until his arm was amputated in an accident. And music was his life, and that was really devastating for him. And he asked whether we can use the technology, the robotic music-oriented technology, which is specifically for music because timing is very important in music. So the kind of stuff that he wanted was something that only people who really focus on music and robots together can help with. And what he wanted is to be able to control the stick because he didn't have the palm and fingers anymore. And I asked him if he's willing to actually have two sticks. So one of them will be under his control, and he can be as expressive as he used to be. And the other one will improvise, and hopefully will inspire him and create new music and explore a new experience where actually your own body is not fully under your control and maybe pushes you to new directions. And here's a couple of videos to see. I think this first video is the first time Jason came. It took about a year for us to develop the arm for him. It used EMG. He will show exactly how it works in a second. But this is his experience when he first tried it.
Flex.
So he flexes his muscle here, and the stick responds.
Flex.
If you see his smile now, you may wonder what is he thinking, because what happens is that both sticks play differently, very fast. Each stick can play up to 20 hertz, faster than any human, 20 hits a second. So not only he got back what he was able to do, he got much more. And now he can play like no human can. And here are some examples of how it works.
In this video, I demonstrate how I control the robotic drumming prosthesis using my forearm muscle. The EMG electrodes attached to my arm send very low latency signals to trigger the robotic stick when I contract my muscle. This allows me to operate the arm in different ways. For example, I can trigger a hit with every contraction, or toggle between different automatic drumming states.
And here is in performance in Kennesaw State University. Actually, what's interesting about this performance, the speed of the stick, of one of the sticks, is controlled actually by the guitar player. So different chords that it plays, we're analyzing the guitar, and it changes the speed and the rhythms that the stick plays. And Jason has in real time to kind of adapt to the new rhythms that his own body plays, which are not under his control. And I think he's doing it very well. This is after several months of rehearsals. But he's really got, the machine and the humans got to be one, as I hope you can see here. The next project, which we're also actually looking to commercialize, we call it the Skywalker project, if you saw the movie. And if you remember, the arm of Luke was just reconnected, some kind of a bionic arm, and immediately was able to control his fingers, finger by finger, which is technology that currently doesn't exist. And we're actually using deep learning in order to get information from the muscle and allow, hopefully, Jason, we're currently in the development phase, to be able to control finger by finger. He will, hopefully will be able to type. This can have other implications for virtual reality and remote control of robotics and many others to create dexterous control by using deep learning on the muscle. Here's our first example. So we're sensing the muscle, and he's able to control the different fingers. On the left hand, he just shows what he's thinking about controlling in his amputated arm. So this is just a demonstration. But this is an example of the technology that hopefully we'll be able to achieve within a year. And the last project I wanted to show is the third arm project. We thought, this was pretty successful actually, the arm. We have been traveling internationally, performing with the arm, and Jason has been the rave everywhere. He's coming, everyone is interested. He has emails from drummers that wish they would lose their arm so they can play like him. So we said, okay, so why not develop a third arm that everyone can, everyone will be able to have superhuman capabilities and playing faster than human and creating all kind of interesting rhythms. So this is Tyler White, a student in my group, and the arm that you're going to see is controlled by multiple things. First, we have a vision system that knows where he's moving his arms, and based on that, the third arm knows where to move. Secondly, you will see just the beginning of research when we're actually looking at his brain signals. He will wear an EEG headband trying to help him because there's so much cognitive load on manipulating and controlling your four limbs, so we want directly maybe for your brain to be able to get some information to help navigate the arm. And also, just like any other robotic musicians we develop, the arm listens to the music, and based on that, it tries to improvise a little bit and surprise the human.
It remains horizontal, whatever we do. That's helping when the player is vibrating a lot in their shoulder.
Teach the robot actually how to move, and then it's recording the movement and then play it back.
We can probably retake that.
All right, I'll be here around if you want to hear more about this project, and thank you very much. Appreciate it.